So, what we are trying to understand, whether fixed effect transformation is applicable for dynamic panel data model. Right. So, this is our, first of all, what was our fixed effect transformation? Let us revise once again. Yit equals to beta xit plus ai plus vit. So, this was our model, and fixed effect transformation means, as you all know, that this is nothing but time demeaning, right. So, yit minus yi bar equals to beta xit minus xi bar, then ai will get cancelled out, and this is vit minus vi bar. That is called fixed effect transformation. This is Fe. And same thing we will try to apply in the context of a dynamic panel data model. So, dynamic panel data model is this: yit equals to beta 1 yi t minus 1 plus beta 2 xit plus ai plus vit. So, same fixed effects transformation we are trying to apply here. So, this will become yit minus yi bar equals to beta 1 yi t minus 1 minus yi dot minus 1. This is basically, this is nothing but yit minus, I will explain what is yi dot minus 1 bar plus beta 2 xit minus xi bar. Ai will get cancelled out, this will become vit minus vi bar. Now, let us define what is yi dot minus 1 bar and what is xi bar, what is vi bar. So, yi dot minus 1 bar is nothing but summation t equals to 2 to capital T yi t minus 1 divided by t. Okay. So, t equals to 2 to t this, and then xit equals to sum of t equals to 1 to capital T xit this, and this is vi bar equals to sum of vi t running from 1 to t divided by t. Okay. So, this is how we have defined this yi dot minus 1 bar. So, this which is nothing but summation yi t minus 1, where t running from 2 to t, yt to 2 because we have taken the difference. So, that is why one observation is lost. So, while summing over, we are taking the summation from t equals to 2 to capital T. Okay. But in xit and this is xi bar and this is vi bar. Now, if we look at carefully, since vi bar actually the sum of vi bar is what, which is nothing but t equals to 1 to capital T. So, obviously, within this vit minus 1 is also there. So, that means I can write that the way I have defined, the way vi bar is defined, it captures vi t minus 1 also. That is by simply by construction of vi bar. Okay. And you see one of your explanatory variable is yit minus 1. Since vi bar contains vit minus 1, so that means what I can say that yit minus 1 minus yi dot minus 1 bar will be is correlated with vi bar because the latter, because vi bar contains vit minus 1. Okay. Obviously, yit minus 1 would be correlated with its own error term vit minus 1. So, that is simply by construction. Okay. So, even though vit they themselves are not serially correlated, the way we have modeled this dynamic panel data, you see one of your explanatory variable which is yit minus 1 minus yi dot minus 1 bar is actually correlated with your error term, which is basically vit minus vi bar, because vi bar is actually contains vit minus 1. Okay. So, basically that means what I can say is correlated with instead of writing in this way, I should write vit correlated with basically the error in difference form vit minus vi bar. So, this shows that fixed effect transformation is also not helpful to estimate a dynamic panel data model, because what is happening, even though we were able to eliminate the AI component, we are not able to rule out the possibility that one of your explanatory variable is getting correlated with the error term. What is the error term we are talking about? vit minus vi bar, the transform error term. And what is the explanatory variable here? yit minus 1 minus yi dot minus 1 bar. Okay. So, your explanatory variable is this, which is correlated with the error term. So, OLS is not applicable, that means fixed effect transformation, which shows that FE transformation is not applicable to estimate to estimate a dynamic panel data. Dynamic panel model, because explanatory variable is getting correlated with the error term. Now, we have learned one more transformation which is called first difference. Let us see, when fixed effect model transformation is not helpful, let us see whether we can go for the first differencing of the model, the dynamic panel data model, and apply OLS, right. So, this is our model yi t equals to beta 1 yi t minus 1 plus beta 2 xit plus ai plus vit. Okay. What we will do? We will see whether first differencing of the model, whether first differencing is applicable. That is what. Okay. So, if we do the first differencing, what will happen? If D implies yi t minus yi t minus 1 equals to beta 1 yi t minus 1 minus yi t minus 2 plus beta 2 xi t minus xi t minus 1 plus vi t minus vi t minus 1, and once again we are able to eliminate this ai component. Okay. What is happening? So, in this case we can again clearly see that the error term contains vit minus 1, one of your explanatory variable contains yit minus 1. So, once again one of the explanatory variable is getting correlated with the error term. So, this implies yit minus 1 minus yi t minus 2 is correlated with vit minus vi t minus 1, because the latter contains vit minus 1, and when they are correlated, that means again endogeneity problem. Okay. It leads to endogeneity problem, that means once again OLS is not applicable. That will lead to bias. Okay. If we apply OLS in this context, that will lead to bias. Biased estimates of beta 1 and beta 2. Okay. And this bias is of order 1 by t. Okay. So, in a dynamic panel data model, what I am saying that neither fixed effect transformation nor FD is applicable, because one of your explanatory variable getting correlated with the error term, which prevents the application of OLS in this transform model, which we were doing earlier in the context of a simple one-way fixed effect model. If we do so, if we do estimate a dynamic panel data model the way we learned in the context of FE and FD, that will lead to a bias, and that bias is of order t, 1 by t. This bias is also known as nickel bias, N-I-C-K-L-L, nickel bias, because Nickel, the famous econometrician, he was the one who introduced this type of bias in the literature. So, what we can understand, in a panel where t is small and n is large, that means basically a micro panel. Okay? So, there are two types of panel. What do we know? That a panel data model, if you recall, micro panel and a macro panel. In micro panel, basically you have large number of n. So, large n, but small t. And macro is basically large t and small n. If your panel is of this type where n is large but t is small, you can understand that bias will be huge, right. So, bias is large. Okay, bias is large, but when macro panel t is large and n is small, for example, when you are constructing a panel with, let us say, only 4 or 5 countries and you have large number of time period, let us say 50 years data, then this bias, so that means the bias, as you can understand, bias tends to 0 as t tends to infinite. And when t tends to infinite, basically we are talking about the macro panel where large number of t and small number of individuals are there. Okay. So, famous econometrician Nickel, he first introduced the problem, this type of bias, that is why it is called nickel bias of order 1 by t, which happens if we apply fixed effect transformation and FD to estimate the dynamic panel data model. Okay. So, neither fixed effect nor FD is applicable. You can apply FD, this type of first difference transformation, only when you have a large number of t. But even when t is equals to 30, the bias is 20%. You can understand t equals to 30 means it is really a large panel. So, even in that context also your bias is 20%. So, that means the estimates beta 1 hat and beta 2 hat will deviate 20% from their true value. Okay. So, neither FE nor FD is basically applicable because they are leading to a bias which is called nickel bias, is of 20% of their true estimates even when t equals to 30, right. So, that means if we now summarize what we have discussed in today's class, basically a dynamic panel data model where we introduced a lag dependent variable in the system, and that introduces dynamism in the system. And in the dynamism in the system, the moment you introduce that basically calls for this type of two types of persistence over a period of time. One is due to the unobserved effect and another is due to the autocorrelation. So, lag dependent variable creates autocorrelation in the problem. Naturally, the question comes to our mind, can we eliminate AI by fixed effect transformation and get rid of this at least one type of persistence? We tried that and we showed that no, it is not. Neither FE nor FD is basically applicable to estimate the dynamic panel data model. But one thing we have not discussed is what exactly is the context of a dynamic panel. So, that means what are the examples, some examples of dynamic panel data model. So, this is examples of DPD, dynamic panel data model. First one is, we can say that agricultural production. What happens here? A farmer decides which crop to cultivate in period T depending on what was the return from a particular crop last year. Let us assume that last year the farmer earned huge profit from paddy cultivation. So, if paddy cultivation helped the farmer earning huge profit in T minus 1, then in Tth period also the farmer will go for paddy cultivation, and the how much acre of land the farmer will allocate for paddy cultivation, that also depends on what was the relative return of paddy over other competing crops, right. If paddy gave him or her huge profit last year, even this year also farmer will go for paddy cultivation relatively more compared to other commodities. Even in the context of industrial production, let us say last year a firm produces the amount YIT or YIT minus 1, but the firm could not sell that much and lot of the produced item went to inventory. When a large portion of the output or production went to inventory in the previous period, obviously the firm will try to reduce the production of Tth period because that much inventory the firm has to sell first. So, that means a higher YIT minus 1 basically indicates a relatively lower amount of YIT. Very simple, and that is why YIT is related to YIT minus 1. So, both agricultural production, industrial production shows how basically YIT is depending on YIT minus 1. Another interesting example is consumption of cigarette, let us say. So, these type of products, cigarette, alcohol, if you consume, then it builds some kind of habit within the customer. So, at the initial period, an individual will start smoking 1, 2, 3, and each successive period, because of this habit, the consumer will try to maintain that level of smoking. So, how many cigarette I will smoke in period T, that means that very well determined by how much you have consumed in T minus 1th period. Because T minus 1th period consumption shows what is the habit that I have created within myself. How much alcohol I will consume in Tth period, that again is determined by T minus 1th period consumption of alcohol. So, it will go on, this habit formation will go on like this. Then at one point of time, if the consumer thinks that he or she will leave the smoking habit, they cannot do it overnight. So, if my Tth period observation, Tth period consumption is, let us say, 5 packets of cigarette, probably in T plus 1th period I will reduce by half packet, 4.5, next period 4, next period 3.5, in this way. So, that means in the process of habit building, when it is increasing, in that section also we showed that Tth period consumption is basically dependent on T minus 1th period consumption. At the same time, if the consumer is thinking of leaving that habit, the consumer cannot leave it all of a sudden, the reduction will also become a slow process. So, all these examples shows how YIT, that means the variable y in Tth period, is basically dependent on its previous values. These are some examples of dynamic panel data model, how dynamism is required. There are many such examples you can think of from your real life. Most of the economic data are actually dynamic. Most of the economic relationship are dynamic in nature. That means lag dependent variable we must introduce in the model as one of our explanatory variable. That explains the current period value of y dependent variable. So, with this we are closing our today's discussion, and in next class what we will do, when we cannot apply neither FE nor FD to estimate fixed effect dynamic panel data model, because that leads to bias in the estimates, what is the solution? Okay. So, the solution, that means the proper estimation technique of a dynamic panel data model, we will discuss in our next class. Thank you.